Hi everyone, my name is Kesavan Shanmugam, Partner Director of Engineering at Microsoft. I'm joined by Gal Levy, Program Manager from Cosmos DB team. Today we're going to talk about how to build scalable and high-performance applications on Azure using Azure Cosmos DB and Azure Cache for Redis. If you are a cloud-native application developer, your business and your customer are going to demand three things from you: that your application has low latency to your service, often in sub-millisecond range, and that your service scales massively and handles unpredictable traffic and grows along with the demand for your application, and that your service is highly available 24/7 and around the world without any interruption. If your application is based on a NoSQL database, you can achieve these characteristics using Azure Cosmos DB. If your application needs an in-memory cache, Azure Cache for Redis offers the exact same characteristics. With these two services on Azure, you can really build cloud-native applications with low latency, massive scale, and high reliability. Today, I'm going to give you a quick overview of Azure Cache for Redis. I'm going to talk about the general availability of two enterprise tiers. I'll give you a quick run through the features and a short demo. After that, Gal Levy will give an overview of Azure Cosmos DB. We'll talk about Cosmos DB API for MongoDB and its key features. If you're not familiar with Azure Cache for Redis, this is a great time to get to know about it. Azure Cache for Redis is a managed offering on Azure of the very popular open source software. It is blazingly fast with sub-millisecond responses, and it can support millions of transactions per second. It is often used in conjunction with other Azure services like App Service, Azure Kubernetes Service, and Azure SQL DB. Having a blazing fast caching layer in front of your data tier or application instance can really speed up your application and offer you good throughput. It can also be used to reduce costs and scale better without having to over-provision additional data instances or application instances. Azure Cache for Redis is versatile in many scenarios, but I'm going to highlight 4 of them today. It can be used as a distributed cache to scale your read-write operations from your data tier. It can be also used to save, retrieve, and update information in your session stores for often your mobile and web applications. It can also be used as a message broker, for example, in a publish-subscribe architecture or an event-driven architecture. In gaming scenarios, a cache can be used to track the leaderboards for a gaming session. I mentioned earlier that Azure Cache for Redis offers you high throughput and low latency, but how much? We asked an independent third-party company, GigaOM, to do a performance benchmark of the gains you get by using a caching layer. So they built a simple web application, a shopping cart application, where they kept all the inventory and the pricing data in Azure SQL DB. They built another version of the same application with Azure Cache for Redis to speed up the application. And they compared these two versions. With Azure Cache for Redis, they were able to get 9 times higher throughput and 11 times lower latencies. And in both cases, they were able to use smaller instances of the database, thus lowering their costs. All this goes to show that you can really achieve excellent scale and performance by using a caching layer in front of your data tier. Today, I'm excited to announce the general availability of 2 new tiers of Azure Cache for Redis, the Enterprise tier and the Enterprise Flash tier. We built both of these tiers in partnership with Redis Labs, and we were able to bring some of the most popular features of their enterprise offering to Azure. These 2 tiers bring in some differentiated capabilities for your cache. In particular, you can now achieve up to 5 nines of availability. Both support geo-replication capabilities. You can use Redis modules along with the enterprise tiers. Redis modules can unlock new scenarios for you. And with Redis on Flash, you can use really large caches up to 13 terabytes in size. Let's dive a little deeper into active geo-replication capability of the enterprise tiers. With active geo-replication, you can have multiple instances of the same cache spread throughout the world. Each of these caches are connected with the other caches. Any write operations to one of these caches will update the data in all the other caches immediately. With this, you are able to achieve local latency characteristics while still having a globally distributed cache. An active geo-replicated cache will also get you greater resiliency. Active geo-replication can be used in many scenarios, but I'll highlight 3 of them here today. Redis Cache is often used as a session store. For example, if you have a coffee company tracking the user's favorite coffee order from their mobile app, what happens if the user travels from one geo to another geo? You usually end up with the application having much higher latency connecting to the cache in another region. But with active geo-replication, you can have your application talk to the local instance and still achieve local latency. With geo-replication, if one of the caches or application nodes goes down, you still have the entire data available in another instance that you can fall back to. There are also applications where they're inherently global. Imagine a gaming scenario where thousands of gamers are playing games and you want a leaderboard for that gaming session, and you want the leaderboard available in every single region, and the geo-replicated cache can help you do that. For the demo today, I'm going to be using a shopping cart app. It's a simple Node.js app that is deployed in Azure Kubernetes cluster. I have 2 instances of the app, one in the West US and another one in East US. For the shopping cart, I'm keeping the inventory in a Redis cache, and again, I have 2 such instances, one in West US and another in East US. But I've linked them together for geo-replication so that any updates to the inventory in one of the caches is automatically reflected in the other. Typically, in a shopping cart app like this, you would have the application instances behind a traffic manager so that you have a single endpoint that the clients will talk to. However, for the purpose of the demo today, I'm going to keep 2 separate endpoints, and I will have one user in Seattle talking to the application instance in West, and another user in New York talking to the application instance in the East. Here I'm at the Azure portal, where I'm showing you the 2 caches that I've already set up. Each one is an enterprise tier cache, 12 GB cache. One is in East US and another one is in West US. Both have already been configured to geo-replicate from each other. Let's see if we can create another instance that geo-replicates from these 2 caches. So this is a create flow for an enterprise tier. I'm going to use the existing subscription I have where these 2 caches are already. I'm going to add them to the same resource group that contains these caches. I'm going to name it Redis Demo Cache South Central US. I'm going to select the enterprise tier. You can see that you can have standard, premium, or enterprise tiers. In this particular case, I'm going to pick a 12 GB enterprise E10 SKU. And I go to the default setup, leave it with public endpoint for now. In the advanced settings, you can notice that you can use 3 Redis modules. For this demo, I don't need any of them yet. However, here you see that there is active geo-replication capability that is not yet configured. I'm going to try to configure that. In this particular case, I'm going to say that the new cache I'm creating in South Central US needs to be geo-replicating from the other 2 caches that are in East and West already. So I'm going to select that group and go to the remaining settings and go to the final create step. So in this case, we are creating a Redis demo cache South Central US in the South Central region. It's an enterprise E10 cache, and it is already set up to replicate from the one in East and one in the West. I'm not going to actually go to create that. It's going to take a few minutes. For our demo, we just need the ones from East and West. Now that I've shown you where the application instances are running, let's quickly go to how the application is actually used. So here is a shopping cart app where I have 2 clients talking to those application instances. One user is connecting from Seattle to the application instance running in West US, and another user is connecting to it from New York to the instance running in East US. This web store is selling Redis themed t-shirts, and you can see that the inventory of each of the t-shirts is the same in both regions. Even though they're independent caches, they share the same inventory because they're geo-replicating the data from each other. What you should notice is that if I buy one of these t-shirts, inventory should decrease in one of the caches and that it gets automatically updated in the other region. In this particular case, I'm going to buy the one in the middle from Seattle. So I buy now. You should see the inventory go down in both places. There we go. The inventory went from 13 to 12 in both places. If somebody is buying the same t-shirt in New York, the inventory should go down in both places as well. Let's say that somebody in New York is buying all the inventory available for the third t-shirt. 5, 4, 3, 2, 1, and it is now sold out across both regions. This is a quick demo of how you can have the inventory in two separate caches, achieving local latency. However, any updates to the caches are automatically reflected in the other region through the power of active geo-replication that is now possible in the enterprise tier. Now that you have seen the basic capabilities of active geo-replication in Azure Cache for Redis, let's talk about the availability characteristics that are possible with the enterprise tiers. In the default configuration, Azure Cache for Redis offers you 3 nines of availability. You have built-in replication between the primary and the replica nodes, and an automatic failover when the primary fails. So that gets you 3 nines of availability. You also have the ability to place primaries and replicas in different availability zones, and that gets you 4 nines of availability. And with active geo-replication, you can keep different instances of the cache in different regions separately, and that gets you up to 5 nines of availability. Redis Enterprise Tiers offers 3 modules that you can use to unlock new scenarios: Redis Bloom, Redis Search, and Redis Time Series. With Redis Bloom, you're able to check for item membership in really large collections in a memory-efficient fashion. With Redis Search, you get indexing on top of all the cache data, and you can search for any item in the cache in an efficient fashion. And with Redis Time Series, you're able to ingest large amounts of events and be able to query on them in an efficient fashion. As I mentioned earlier, we are announcing the general availability of the enterprise tiers today for Azure Cache for Redis. Later this month, we will announce the general availability of private links. And next month, you can expect us to announce zone redundancy, Redis 6.0, and event grid general availability. With that, I'm going to ask Gal Levy to join me via Teams to talk about Cosmos DB and its new features.
Thanks, K7, for that introduction and showing us all the cool features of Azure Cache for Redis. In this part of the talk, I want to discuss Azure Cosmos DB API for MongoDB and the exciting new 4.0 release. So upgrading is an exciting time for developers. You get a whole bunch of cool new features to use and new ways to access your database. And upgrading doesn't have to be hard. With Azure Cosmos DB, upgrading is as simple as clicking a button. It's so easy a cat can do it. You simply go in the portal or the Azure CLI and you click upgrade, and within minutes, your database is upgraded and you get access to a whole cool new set of features. Let's have a brief overview over what Azure Cosmos DB is. As a developer, I want to focus on what I do best, which is building applications for my users and not having to worry about the database itself. Cosmos DB is really neat because it allows you to not have to focus on scaling your database or doing any other kind of management tasks such as that. It essentially exposes a lever that you can scale up or down your database depending on your throughput needs without having to worry that much about how it's done in the back end. These things are all financially backed by SLAs. Another cool thing is that as a developer, I've worked with different databases in the past, and I really want to be able to transfer those skills to the new databases I use so I don't have to relearn skills over and over again. Cosmos DB is a multi-model database, meaning that you can actually utilize different database APIs that you've come into contact with before and use them with Azure Cosmos DB and not have to relearn a whole new way of accessing your database. And lastly, mission critical is a big word and it's a really important part, but more importantly, your users want to be able to access your applications whenever they want to and not have any downtime to experience with. So Azure Cosmos DB offers up to 5 nines of availability, similar to Azure Cache for Redis, and ensures your applications will always be online. Diving in a bit deeper into that, let's talk about Azure Cosmos DB API for MongoDB. Essentially, this API exposes Azure Cosmos DB as if it were a real MongoDB database, without you having to manage all the infrastructure yourself. That means that the MongoDB tooling that you've interacted with in the past and used is all compatible with Azure Cosmos DB. So you can keep using the same tools and same APIs you were using before. You can also scale Azure Cosmos DB very, very granular because of the resource governance that's built on top of. And that means that instead of having to manage shards yourself, Azure Cosmos DB manages those shards for you. Instead of having to scale in number of VM counts, you can use the scale lever and essentially adjust your throughput to exactly what you want it to be. And lastly, you get all of the benefits of Azure Cosmos DB. So let's talk about the 3 different ways to deploy Azure Cosmos DB. The first one is standard provision throughput, which is really good for workloads that are very constant and kind of continuous, and allows you to exactly optimize how much throughput you need and set it to wherever you want it to be set. And this is very good for optimizing costs for those kind of workloads. Second, we have autoscale, where you tell us exactly how high you want the top throughput you'll ever expect to get to be, and you only pay for what you use based on that. So for workloads that are spiky, for example, let's say you have more users using your software, your applications during the day versus at night, you only pay for what you use. So your workloads can spike up and down, and you only pay for what you use, which is pretty cool because it saves you a lot of money. But even more importantly, this autoscaling is done instantly. So you don't actually have to wait for the scale to come. As soon as your users need it, your database scales immediately. Lastly, we have serverless, which means you only pay for what you use, and you can just throw a workload at it and let it run. And then when it's done, you're not paying for it anymore. And naturally, this is very good for dev and test kind of workloads to save on costs. And now let's talk about what you've all been waiting for, which is the 4.0 release. A big highlight of the 4.0 release is what we call multi-document transactions. Before talking about that, I want to highlight the world before multi-document transactions and how you would handle a certain use case. So before multi-document transactions, imagine you have a user and you have a bank. Each of them has a separate document for themselves that has an amount of money that they currently have. And what you want to do is transfer $100 from the user to the bank. First, you would remove $100 from the user's document, and next you would add $100 to the bank's document. But unfortunately, something goes wrong and the second operation fails. Obviously, the user is frustrated and sad because the $100 just disappeared. This situation can be taken care of with multi-document transactions, where instead of doing each transaction separately, you do these transactions together and they're treated as one single operation. So the removal of $100 from one document and the addition of another $100 to another document are treated as one. And in the case where one portion of that fails, everything fails. And you can simply retry it, then it will succeed and everyone's happy. Diving in a bit deeper from that, let's talk about multi-document transactions in Cosmos DB. So in Cosmos DB API for MongoDB, reads and writes always use strong consistency within a transaction. So no matter what your default consistency level is for your account, strong consistency is always being used within multi-document transactions. Additionally, read-write concerns, which are set on operation level within the MongoDB API or drivers, always use the strong consistency as well. So those get ignored, essentially. Keep in mind that data that's being written to gets locked during a multi-document transaction. And naturally, all of the asset semantics are followed when multi-document transactions are taking place. Some additional tips for multi-document transactions. Things you want to keep in mind. First, only use multi-document transactions for places that require it. You don't want to use it everywhere because there is a performance penalty and naturally a cost penalty to doing so. Make sure when you're using multi-document transactions, you can only use them within fixed collections at this point. They will not work in sharded collections. If you find yourself using multi-document transactions too often, you might want to take a look at your data model to make sure it's done correctly, because multi-document transactions aren't a substitute for good data modeling practices. And with the 4 release, there's more. There's more aggregation functions that will allow you to do less work in your application code and allow you to take advantage of. And lastly, there's increased access to the MongoDB ecosystem, meaning that you'll have access to a whole host of tools that require 4.0 in order to be used. So back to the topic of upgrading. Upgrading is super, super simple to do in Azure Cosmos DB. You simply go to the portal and you click this button. And once you click this button, you have to wait a few minutes, and then all of your databases will be upgraded to 4.0, and you can use it as you like with no downtime whatsoever. This operation typically takes a few minutes to complete, and it's done very, very quickly. Another neat thing you can do is you can also downgrade to version 3.6 from 4.0 if you ever change your mind. You can go between versions very, very easily at a click of a button, which is very neat. And gives you a ton of flexibility to do what you want with your API. We'd love for you to try out version 4.0 of the Azure Cosmos DB API for MongoDB, but always make sure to start off with dev and test workloads first to make sure everything is going well. Secondly, use multi-document transactions only when they're needed, because there's a cost and performance penalty to using them, and you don't want to use them too much. Also, try out serverless mode with Azure Cosmos DB API for MongoDB for your dev and test workloads, because it'll save you a whole bunch of money, and it's very, very easy to use. Lastly, for more information, click here, upgrade now, and learn more about Azure Cosmos DB API for MongoDB. Thank you very much.